So if we wrote down, like if we wrote down our half reactions correctly, then when we add the electrons, they should always be on opposite sides
Yes.
of the arrow, right?
That's a good thing to check, because otherwise how could it be a redox reaction?
Right.
Remember that in the overall reaction, the electrons on the left have to cancel the electrons on the right, so they balance. But if both half reactions had the electrons on the same side, then they couldn't possibly cancel. Yeah. Okay. Here we've got...
multiply by coefficients now?
Yeah.
Balances.
That's right.
So we'll multiply by 4, the top one.
And this one we didn't need to balance. So that was our step E. We balanced the electrons by multiplying the equation. Okay, so what's our new equation?
4Ag S plus 2Cn. Oh, I mean 8Cn.
Goes to 4Ag CN2 plus 4.
Good.
Plus 4.
And then what?
We
Now
forgot
we
minus
add
again.
Because now the electrons balance. All right, so let's see what's going to be our final equation.
No, we forgot minus.
Did I make a mistake?
On the CN2.
I did it again. I really should call this a -1 because I kept using those dashes. Okay, so now what's our overall equation?
4Ag solid plus 8Cn 8 minus aqueous
Good.
plus 4H plus
Good.
aqueous
Good.
plus O2 aqueous? Yeah. No, gas.
That's right.
And so they stay in the same phases? As the
Yeah, we use the
original
phases that we
equation?
were given as our information originally. Good.
And then that will go to 4Ag CN2 minus.
Mm-hmm.
And water. 2H2.
And
Yeah.
these silver cyanide compound, what phase is that?
Aqueous.
Aqueous, good. And plus the 2 waters?
2 waters, which would be liquid.
Liquid. And that's it. And again, you don't need to bother writing the electrons because they've canceled. Good.
What about basic? So this is a basic.
Well, so this is the acidic, right? So then we have to
No,
change it to
that's-
basic?
Good. It's good that you remembered that. That's right. So
Yeah,
now
I
what?
got it.
No, I was like, because I'm like, it says basic. and
That's
I'm
right.
like,
This was
what
very
does it
important
say?
information here. Okay. So this would not be the right answer. So what do we do now?
Continue.
Yeah, we continue. How so?
Let's just add something. We like adding.
So we're gonna add the OHs
OH
to the left side.
How many?
to 4, because we need to get
4. And what are we adding exactly?
hydroxide.
Yeah, so OH minus.
OH.
Yes, OH minus.
Good. Okay, good. So I wanted to make sure that you guys remembered that it's not legal to add 4 hydroxides to the left unless we also add 4 hydroxides to the right. You both remembered that. And it looks like you're seeing that we can cancel these 2 waters now. And that leaves us with only 2 waters here. Now we're ready to write the final equation.
So, do we need to use our rule solubility here?
One moment. What's the phase for the hydroxides?
Aqueous.
Right? Okay, good. You were asking whether we have to use solubility rules?
Yeah.
You mean, for example, to figure out whether these will really dissolve
Yeah.
or not? And the answer is no, because we were already given the information that it is dissolved.
Okay.
We've already been given the
So
information.
whenever we say redox, it means that it's dissolved.
Well, when you say aqueous, you know that it's dissolved. The fact that this is aqueous means that it's already been successfully dissolved in the solution. And that this is going to be formed dissolved in the solution. Any of the ions here are going to be dissolved in the solution. So we know that some of these are going to be capable of dissolving in the solution. So they're not asking us, so we're not really generally going to use our solution skills for these types of problems.
That's good.
Now, yeah, now we should double check this. How do we double check? Well, you would check that the silvers balance, 4 on the left and 4 on the right. You would check that the carbons balance, 8 on the left, and 4 times 2 is 8 on the right. Same thing for the nitrogens. You would check the hydrogens and the oxygens balance, and you would check that the charges balance, -8 on the right and -8 on the left. Okay, so it's good to double check all of that, but here we have our overall equation. All right, so here we, the key part to highlight here is getting the half reactions. How are these different than before? Well, first of all, we had one half reaction here with 2 different starting materials. Well, sometimes that can happen, so you have to watch out for that. How do we know we needed both of these? Well, clearly this was going to be on the right-hand side, and there was just 2 different sources for the silver and the cyanide. And then this also seemed weird because remember at the start, we wrote it with nothing on the right-hand side. And we had to resist the temptation to put hydroxide here on the right-hand side because that would mess up our method. How did we eventually end up balancing these oxygens? We ended up balancing them with water, just like the method says we should. So this would be a good problem to try again to make sure you can do it on your own.